Let's understand factors and multiples in this video. Have you ever wondered why some numbers fit into others without any leftovers? Or how we find a small box size that can hold different groups exactly? These ideas are all about factors, multiples, HCF and LCM, and they help in many problems. A factor of a number is a whole number that divides it exactly, leaving no remainder. A multiple of a number is the result when that number is multiplied by any whole number, and there are infinitely many multiples. For example, 42 equals 7 times 6. So 7 and 6 are factors of 42, and 42 is a multiple of 7 and 6. Now let us look at quick rules to check divisibility, so we skip long division. A number is divisible by 2 if its last digit is 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of its digits is divisible by 3. A number is divisible by 4 if the number formed by its last two digits is divisible by 4. A number is divisible by 5 if its last digit is 0 or 5. A number is divisible by 6 if it is divisible by both 2 and 3. A number is divisible by 8 if the number formed by its last three digits is divisible by 8. A number is divisible by 9 if the sum of its digits is divisible by 9. A number is divisible by 10 if its last digit is 0. A number is divisible by 11 if the difference between the sum of digits at odd places and the sum at even places is 0 or a multiple of 11. Let us try some solved examples to make this clear. Question number 1 asks about divisibility by 3 for the number 32,592. Add the digits 3 plus 2 plus 5 plus 9 plus 2 equals 21. And 21 is divisible by 3. So the number is divisible by 3. Question number 2 asks whether 9,072.8 is divisible by 11. Sum of digits at odd places equals 8 plus 7 plus 9 equals 24. Sum at even places equals 2 plus 0 equals 2. Difference equals 22. And 22 is divisible by 11. So the number is divisible by 11. Now we move to HCF, the highest common factor, also called greatest common divisor. HCF is the largest number that divides each of the given numbers exactly. Question number 3 asks for HCF of 144 and 198 by prime factorization. Prime factors of 144 are 2 times 2 times 2 times 2 times 3 times 3. And of 198 are 2 times 3 times 3 times 11. Common prime factors are 2, 3 and 3. So, HCF equals 2 times 3 times 3, which is 18. Question number 4 asks for HCF of 513 and 783 by the division method. Divide 783 by 513 gives quotient 1, remainder 270. Then divide 513 by 270 gives quotient 1, remainder 243. Then divide 270 by 243 gives remainder 27. And dividing 243 by 27 gives remainder 0. So the HCF is 27. Next, LCM is the least common multiple, the smallest positive number that is a multiple of each given number. Question number 5 asks for LCM of 6 and 8 by listing multiples. Common multiples are 24 and 48, so least common multiple is 24. Question number 6 asks for LCM of 24, 36 and 40 by prime factorization. Prime factors show highest powers are 2 3 times, 3 2 times and 5 once. Multiply 2 times 2 times 2 times 3 times 3 times 5 gives 360 as the LCM. A useful relation is that for two numbers A and B, A times B equals HCF of A and B times LCM of A and B. Using this, question number 7 gives HCF 23 and LCM 1449 and one number 161, we find the other equals HCF times LCM divided by the given number, which gives 207. So what do we learn from this? We learn how factors and multiples link, how divisibility tests make checks fast, and how prime factorization helps find HCF and LCM. Let us quickly remember the key points. Factors divide exactly, multiples come from multiplication, HCF uses common prime factors taken with lowest powers, and LCM uses highest powers. So today we learned simple tests and clear methods to solve real problems with HCF and LCM. Keep practicing these steps, take small examples, and you will get faster and more confident. Explore more practice questions and explanations on EduRev, and keep learning at your own pace. You are doing well.